All right, so this is the homework help video with Ansley. And Ansley, did you bring a question or two for us to look at today?
Not really. Probably a lot of questions actually, but nothing right off.
Okay, are there any concepts or anything that I can help you understand? This is really for you to kind of clarify some things for yourself, either in homework or just general concepts that you'd like to chit-chat about?
I know that I was doing, I think it was the 1.1 or 1.2 earlier, and I had some trouble with it, was when there were fractions inside. I was having trouble with that, like when there's the negative and all that.
Okay, let me take us out to the web together so we can look at my math lab and maybe we can identify a problem like what you're thinking of.
Okay.
Just a minute. And you're seeing my desktop?
Mm-hmm. Yes, ma'am.
Okay. All right. I'll show you how beautiful my desktop is because this was taken off the balcony at my house. Isn't that awesome?
Oh, it's beautiful.
That was a couple weeks ago. The winter sunsets this year have been beautiful. Okay. Let me open the book here so it'll let me get to the questions and the video. Okay. Let's see if I can find the question. Come on in. You're fine. I've got. No, you're fine. You can just come sit in and use. There, I do. I have a student right here. One of my colleagues says, "Hi, student."
Hi.
Okay, Ansley. And you can, behind the ears, you can do the wrist, the neck. Okay, sorry, we're talking about essential oils. My colleague says you're missing out on the smells in my office. I've got my essential oils out. We're having a girly essential oil time. Okay, so this doesn't have any fractions in it. Let's see. You're so welcome, friend. You do the same. Give me a call if you need to chit-chat. Okay, X and Y intercept. Translating. Ah, there's some fractions. Is that like what you're talking about?
Kind of. It's like when they're, the fractions are inside of it, when you have to, same sort of concept.
This is going
to work on there a little bit harder.
Yeah, this is going to actually have you putting a fraction in the denominator and having to take that compound fraction and make it into just a single fraction. So if you're having, okay. Let me put it to memory here because it won't let me draw on the screen while I'm sharing my desktop. So let's see. 1 over x, and let me write this down. Memory is not the best. So -2, -1, -1/2, +1/2, 1 and 2, and it is y equals 1 over x. So basically it's asking us to just create an XY table using those values. And this is actually really good that you brought up fractions because fractions are one of those F words for students. Fractions, factoring, and word problems students usually hate. So I'm sure everyone will be eternally grateful to you for bringing fractions up to me. So real quick, I'll spit out your list of rules for fractions, and when I teach fractions to my elementary algebra students, I don't teach them as just a list of rules. We take a lot of time to really understand why it is the way it is. But since that's not really the point of the problem, I'll skip the why and just give you the how-to. So, fraction how-tos. Okay, so with multiplying and dividing, actually I shouldn't put those together. We'll just say multiplication first. With multiplication, you multiply fractions straight across. In other words, numerator with numerator, denominator with denominator. Okay? For example, 3/4 times 4/5 is 12/20. So 3 times 4 is 12, 4 times 5 is 20. I'm actually going to show you how to reduce fractions right here. Now, a lot of times when students are actually turning in papers, here's what I see for reducing fractions. Okay, well, 4 goes into both of these. 4 goes into 12 3 times, and 4 goes into 20 5 times. Sorry, that's really bad, which is 3/5, which is fine, especially at this stage of the game, but I'm going to show you why it works like that. So this is 12/20, which is the same thing as 4 times 3 and 4 times 5. And basically what you're doing when you're reducing fractions is you're dividing out common factors from the numerator and the denominator. So anything divided by itself is just 1. And we know that multiplying with 1 doesn't change something. So we just end up with 3/5 there. So that's why reducing fractions works, because you're really just dividing something by itself and getting it out of the picture, so you don't have to worry about it. Dividing fractions. Dividing fractions, division, you never divide fractions. What you do, and I'm going to make it colored with a star, you multiply by the reciprocal. And this works because of compound fractions and that clever one that's really some number being divided by itself. I won't go into a long explanation of that unless you want it. Do you want a long explanation?
I guess we just go with what you were saying before.
Okay, all right. So this is just going to be the how-to, so it's not going to have all the background. Why does this really happen the way it happens? So we'll take our same two fractions here. So 3/4 divided by 4/5. Okay? We don't do 3/4 divided by 4/5. What we do is 3/4 multiplied by the reciprocal of the second fraction, which is 5/4. Okay? And then you've turned it into a multiplication problem, so you just multiply straight across. 15/16. And that's it. I feel compelled to show you the down and dirty of it, so I'm just going to do it. If it goes over your head, just say whatever, Miss Gore. Especially since this is college algebra, I feel compelled to tell you the why. So 3/4 divided by 4/5 is the same thing as 3/4 big divided by 4/5. which is a compound fraction. Just like we have anything divided by itself as 1, anything multiplied by its reciprocal is also 1. That's actually the definition of reciprocal, is the number that you can multiply by, and the product is 1. So if I'm trying to get rid of that denominator, because that's the no-no there, is having a fraction within a fraction, if I wanted to create 1 in the denominator, I would need to multiply it by its reciprocal. So like 4 times 5 is 20, 5 times 4 is 20, 20 over 20 is 1. So that's what makes those things reciprocals. But you can't just go around and multiply by 5/4 whenever you feel like it. That changes things. The only thing that you can multiply by and not change something fundamentally is 1, because anything times 1 is just itself. So what we actually do is we multiply this entire big compound fraction by a very clever form of 1, which is 5/4 over 5/4. 5/4 over 5/4 is just 1. That's something being divided by itself. So here's what happens. In the numerator, since you just multiply straight across with fractions, in the numerator I have 3/4 times 5/4 over 4/5 times 5/4. Okay, so the numerator is 15/16, and the denominator is 20/20. 20/20 is just 1. That's something being divided by itself. So now you've got 15/16 divided by 1, which is just 15/16. Notice, same damn thing right there. So the little rule of multiply by the reciprocal is not a trick, it's not magic, it's just a shortcut way of doing all of this business down here, because look right here. Let me get a different color to point it out. Use green. Right here at this step, you've got the same thing happening. Are you impressed?
Yeah,
oh yeah, no, I completely understand how quickly we forget. Math is very much a use it or lose it subject, and so, you know, this is not hurting anybody to go over these fraction rules like this. Okay, so that is multiplying and dividing. I'm going to clear the screen to go for addition and subtraction. Really, addition and subtraction we can do together, because at this point it's really just combining positives and negatives. We don't really even have to think of it as addition and subtraction anymore. So I'm just going to, ooh, I thought I was about to clear. Now I'm going to clear. All right. So let's talk about addition and subtraction together. With addition and subtraction, if the denominator is the same, you're sitting on easy street. So 2/7 plus 3/7. Well, all I'm doing, whenever you're adding and subtracting whatever kind of number, all you're trying to do is gather up how many of the same thing that you have. Since these are both wholes that have been cut into pieces called sevenths, they're the same size. So I can gather them up and say, I've got this many of that thing. It's not until you get different piece sizes that you can't call them and call them the same thing. So I start out with 2 of these things that are size 7ths. Add on 3 more of those things that are size 7ths. That gives me 5 of these things that are called 7ths. So when you have a common denominator, to add or subtract, so if I put a subtraction symbol between those 2 things, 2 7ths minus 3 7ths equals, that's the same thing as saying I started with 2 of these things called 7ths. I took away 3, I'm in the red now, -1 7th. So the rule says when you have like denominators, you combine the numerators over the common denominator. Notice the denominator didn't become 14. I don't add my denominator. My denominator is just there to tell me what size piece I'm dealing with. Not going to change if I gather up more of those same size pieces. Does that make sense? Very good. Okay, now here's where it gets hairy, and that's when you have different denominators. So we'll take 3/4 plus, we'll do 2/3 to keep the numbers nice and small and neat. Well, I can't just start gathering these up and say, oh, I've got 5 4/3. There's no such thing as a 4/3. Those are 2 different piece sizes. It's the same sized whole. This is going to be super bad, so bear with me. You'll have to use your imagination on the same size whole. Cut into different piece sizes. This one's cut into 4ths. This one, however, cut into 3rds. So you can see the dilemma that you fall into when you start trying to gather up same size pieces. You don't have same size pieces. Okay? So this is where we have to find a common denominator. The only means that we have of finding a common denominator is by multiplication. So we want to figure out, okay, what is, we call it the least common denominator. That's the smallest number that both of the denominators are factors of, or they both go into this number. So obviously between 4 and 3, our common denominator is 12. So then you've got to decide, okay, what do I need to multiply each of these denominators by to make it 12? Well, with the first one, you would need to multiply by 3. Once again, though, you can't go around and multiply by 3 whenever you feel like it, because that changes things. So we multiply by the clever form of 1, 3 over 3. So that's 3 over 3 multiplied by, because that's just 1. I'm not changing the fractions 3/4. I'm just making it look different. Same thing with the 2/3. I want to multiply by the clever form of 1, 4 over 4. Now let me show you in the picture what that comes to do. What happens is I dice this into thirds the opposite way. And it says I have all 3 of them, 3 out of 3. So I'm going to use a lighter color. Come and say, it says I have all of these. The place where they overlap, 1, 2, 3, 4, 5, 6, 7, 8, 9, and I have 12 whole pieces. Look what happens if you multiply these two fractions together. What do you get? You get 9/12. So that's a picture of what's happening up top. Same thing on the opposite side. I come back and dice the other direction into fourths, and if there weren't human error all over these drawings, they would look like the same size pieces. I have all of them because I've got 4 fourths. They overlap. One, 2, 3, 4, 5, 6, 7, 8, and I've got 8/12. So getting back to our actual calculation up here, multiplying fractions straight across gives me 9/12 plus 8/12, which leaves me with 17/12, because now I'm gathering up the same sized pieces. And in our picture, this is what would happen. Whoa. 1, 2, 3. So there are 12 pieces there. I need another whole. God, I'm so sorry. That's terrible. 1, 2, 3. Okay. So my purples, I have 9 of those. 1, 2, 3, 4, 5, 6, 7, 8, 9. And my yellows, I have 8. 1, 2, 3, 4, 5, 6, 7, 8. I could change this to a mixed number and say 1 and 5/12. Not really a useful form to have it in here. I'd much rather you leave it as an improper fraction. Or I can just count up my pieces that I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 12. Good, good. You want to go back and look at that problem of plugging the fractions in, or was this enough to get you going on fractions?
No, I think that's enough, yeah. I don't think I was just, the memory.
Math is very much like riding a bike. You lose it for a time, but as soon as you get back on, it starts all coming back to you. So. All right. Well, I won't waste any of your time this afternoon. I hope this is helpful for you. Thank you for coming with another good topic. I've had 4 good videos now, and I'll post this as soon as it comes through in my email in a few minutes for everybody else to benefit from.
I can just do this.
Yeah. We don't have to make a video every time. You've met your requirement for the homework help video. But if you don't mind me recording a session like this, it helps everybody to be able to see stuff like this. But if you want to just keep it between you and me, we can schedule this anytime. You use the same appointment scheduler. Those are my office hours that are open, and so I'm willing and able to do this. Okay, that's fine. Have a wonderful weekend, Ansley. Thank you. Bye-bye.
Thank you, you too.